Our final speaker, Dave Hughes from A123, which is a pioneering company in what is probably the most exciting space in technologies today, that is energy storage and batteries. They're working on some real path-breaking technologies for energy storage on board. And I actually had the privilege of being in the same material science laboratory back at MIT 20 years ago as the founder of A123. You'll know, of course, that Yap Min Chang has gone on to great fame and fortune and may have created a company and the technology that's going to save the world. I ended up as a journalist. So you can kind of work out which of the two of us was the cleverer of the two in the lab. In any case, I'm delighted to have Dave on our panel. If you can give us an overview of, again, what in many ways is a linchpin technology that could well prove a snag. It could be a great obstacle or one of the wonderful enabling technologies.
Sure. Thank you. Well, being a battery guy, when we look at the plug-in hybrid revolution, we think it's all about the battery. But truthfully, when you listen to the transmission issues and all the other infrastructure issues and the vehicle issues and so forth, it's a pretty big problem that we've got. But unlike Shai's business, where you can start with existing technologies, when we came out 6 years ago, what we had to do, if you want to start an American battery company, is we went over to MIT and licensed some new lithium-ion chemistry that had some great promise for changing the way we would perceive performance of battery technology for transportation. And you throw in a Department of Energy 100,000 SBIR grant to get yourself going, go out and raise some money, hire some bright scientists, and then go about the process of trying to build batteries that actually take advantage of the new chemistry and prove that it will work. So from that start, of course, we're looking at the automotive business as a great opportunity for this technology. If you looked at the hybrid vehicles that we drive today, that we enjoy today, that have changed the landscape for us, the batteries in those vehicles are, I would call, 5 or 10-year-old technology, effectively. And although they're very, very good performers, they're relatively heavy and large for the amount of mileage that you get from them. In the typical hybrid today, if you just drove pure electric on it, you'd get maybe a mile or two out of that, and it would give it up. And the barrier that's kept the industry from going forward is having both cost-effective and performance-effective batteries that could fit in the vehicle and provide the long-term performance that you really have to have. So we started out with what we call nanophosphate technology. It provided an advancement in the size and the weight, the overall power we could deliver, and certainly some improvements in safety over other lithium-ion technologies that had been on the market at the time. So a significant technology breakthrough, to say the least. But we really didn't have a big demand for batteries for automobiles at that time. If you went around the industry, which we did, there wasn't an opportunity really for big improvement or big access to the market in batteries, certainly in North America. So while we were waiting for $130 a barrel for oil, we hooked up with Black & Decker, who makes a lot of cordless power tools, and we developed systems that would allow them to advance the power tool industry and by building batteries. And so we built and have built millions and millions of batteries now and have proven that we could make this technology scale that we had while we were waiting for this PHEV revolution. And we came across a little company in Canada called High Motion. And they had what we think was a really cool idea for how you could take an existing hybrid vehicle and you could advance it into the plug-in hybrid world. And at first, from our view, it was a demonstration. And the importance of the demonstration was that the industry, by and large, didn't get the idea, and maybe still to a great degree today, that a plug-in hybrid really made any sense at all. And the only way you do it is you got to build something. And short of building a new car and starting from scratch, you start off with existing cars. And this idea was basically leave the car basically alone, but add a reservoir of energy to the back of that car. Add energy to it so you could increase the electrification of the vehicle. Don't change the vehicle in any significant way other than adding this amount of energy. And if you could do that, and you can get 100 miles per gallon, you're going to get the attention of people. And so what we did is we acquired that little company, we put it together with our people. We added the financial resources and the technical resources to provide safety testing and durability testing and crash testing and the things that you need to do if you're going to play in this particular arena. And today we've got that High Motion product ready for launch for public consumption and for fleets around the country. Then we got together with BAE Systems. It's a maker of hybrid drive systems for buses, and they supplied the Daimler bus system that drives in New York. and we helped them develop a system using our new technology that allowed them to save 3,600 pounds per bus in weight of battery systems by using this new technology, and more than double the fuel mileage. And those are running in commercial service in New York City today. And we've engaged with a large number of automakers and new car companies with new models in which to create the batteries for the volume population which we're all looking for. So over the next 2 to 3 years, we expect to see a number of hybrid vehicles, a number of plug-in hybrid vehicles, and certainly a number of electric vehicles, pure electric vehicles, that will be out driving around our streets, and we're very proud to be a part of it.
Very good. So we've heard from a range of experts on the topic. I'm going to take the chairman's prerogative to ask them some questions of my own, but I encourage those of you with questions to start forming a line here at the microphone. We are webcasting this, so we do want you on the mic for the questions, please. So I'll turn to those questions in a moment. But first, let me turn to my panelists. Shai, the two countries you're working in first, Israel and Denmark, present interesting two questions in my mind. First of all, these are both obviously small countries, right? Relative to, say, the United States, a continental economy like the United States. Is this an infrastructure play of the sort you're working on that is amenable to small countries but might be quite difficult on a continental scale? And that's something maybe Mark can weigh in on from the grid perspective as well, are the challenges. And does that perhaps suggest that we might have multiple solutions in different parts of the world?
So I think there are multiple solutions for different time frames in the world. If you have zero infrastructure, obviously a plug-in hybrid vehicle makes more sense than a swappable battery until you got to swap stations. Now, the question is, when do you get the infrastructure in place? Not do you get the infrastructure in place? Because when you look at the cost of putting infrastructure in place is much cheaper than carrying your own power plant with you in the car. So when you're looking at it from a global market perspective, you would rather do something in infrastructure if people share in it, just like we do the grid. We have a few people with generators at home, but not most people have generators at home. Now, could you do the US? And let's start with that question. And I think if we look at the mobile phone metaphor for a second, when we bought phones, 15, 20 years ago in the States, we used to get coverage maps, right? And it would say, here's the coverage map for this region this year, 6 months from now, a year from now, a year and a half from now. Now we know there's terrible coverage everywhere you go, but you sort of have the same coverage everywhere. Right. What we're doing is basically looking at it from the same kind of perspective. Draw a 120-mile circle around every city on the west side of the United States, and you'll get these transportation islands. LA is one. Well, most Angelinos don't know there's anything outside LA. You just go in a circle. But then you go on one artery, and it connects you to the next island. It's Vegas, where most people go in and out of the Strip. You could create these circles of coverage, and when you created coverage, you're free to go. On the east side, these circles actually overlap with each other. So the New York circle takes you all the way to the edge of Long Island, takes you all the way to Philly.
Does this make sense, Mark, the cell phone model of rolling out coverage?